Welcome to another practical physics walkthrough. This is part of a sequence, and today we're going to be looking at resistivity of a wire. It's a fairly simple circuit, but you'll have to set it up yourself. You need to make sure that you can use a multimeter, and ultimately you're going to be calculating a value from a gradient. So let's have a look at the kit. We've got a setup here where we've actually got a wire that is being set to a meter ruler. We've done that for you, so you don't need to do it. And you're just going to need to make note of where it's connected, because it's not 0 point. But ultimately, that's all done for you. We've then got two multimeters, one of which is being used as a voltmeter, the other one being used as an ammeter. We've got a protective resistor in there. You don't need to worry about that too much until the calculations later on. And we've also got a little slither of copper that's attached to one half of the voltmeter so that you can take lots of readings along the ruler, and it's being acted as a jumper. When you set this up, you'll just have to go and get all the equipment from the various parts of the lab, and you'll have to get a couple of voltmeters. And what we expect you to do is to be really careful, because it's very easy if you just short a battery across an ammeter to blow a fuse. If you blow a fuse, please let us know. This is currently set as a voltmeter. There's both AC and DC available, and this is in the 2 volt range. As this is a 1.5 volt cell, the 2 volt range is perfect. This is set up as an ammeter, although this is set up as an ammeter. So we're going between the A and the common. With the voltmeter, we're going between the volt and the common input. Whenever you're working with an ammeter, if you're likely to get more than 2 amps, use a 10 amp, otherwise use a 2 amp. And then, to be honest with you, you can play around to get the sensitivity that is going to be most appropriate for you. If you get this -1, that's just an overload error code. So if you get that, you've got to go back up the scales, and we've got, what's it, 98 is settling on, and we're in the 200 milliamp range. So, just moved up and down a little bit just so we're moving it. But we're in the 200 milliamp range, and that just simply says the maximum current that's available for this range. So it's just in milliamps, so that's 99 milliamps. If I put it to here, you can see that they're not perfectly matched, but basically that's saying it's 103 milliamps. Look, there's the decimal point, so it's 0.104, 0.103 amps, and of course that's roughly the same as 100 milliamps. When you're doing this experiment, we expect you to take some careful measurements. To be honest with you, hopefully that ammeter will be roughly constant, but I'm just going to pop this down like this. But when you're taking, some horrible glare there, sorry, when you're taking readings with the voltmeter, you are going to need to be really careful what measurement you're taking out for the length, and to record the voltmeter value accurately. So you need to get it nice and still, nice and vertical, press down on it, and you should get a reasonably steady reading. If it is floating like this, you've just got to give it a minute and try and take a value that is sensible. If it's floating a lot, you might need to change your cell. Okay, so there is a chance that if it's really drifting a lot, then your cell's on the way out. So it's up to you what measurements you take, but you've got the full, almost the full meter ruler, and you need to make a decision where you're going to get roughly 8 readings from this setup. Once you've got those 8 readings, you then need to refer back to the sheet and basically follow the analysis for it. By the time you reach the resistivity of the wire experiment, it might be that you haven't yet done this in your A-level classes in theory. So, I expect you to read the sheet, make sure you understand a little bit of theory behind it, and of course you can look at any of the other resources that we point you to actually have a little look at the theory. Obviously you've got the textbooks, but I really like Antoine Education. I think it's an excellent revision site, and it's got just the level of detail for you to have a little look. If we quickly look at the electricity section, you can see that this is literally mapped to the AQA spec as well. It's brilliant. And we've got a section on resistivity, and if you go there, you can read all about resistivity, exactly what it is, its relationship to resistance, and it's even got this experiment and how to analyze it. So you'd be mad not to have a little look at that beforehand so you knew what was going on. We've got the circuit diagram which matches the kit, and we've got full instructions about how you set it up. Now you've seen it, hopefully a little easier. The analysis for this is actually relatively straightforward. There's a couple of things to look up, and you can either look at the relationship between standard wire gauge, SWG, and diameter. Of course, you've taken the measurement for diameter already, and you've used whatever instrument you felt was appropriate. I guess your possibilities are a meter ruler, vernier calipers, or micrometer, and hopefully you pick whichever one you think is going to be most sensitive for that. As always, we want you to look at the theoretical value for resistivity for constant time wire and compare it with your values. Once you've done that, you always cite your source. So if you've used Yarwood and Castle, you put Yarwood and Castle, you put Macmillan, you put 1971, whatever the publishing date is. If you've used the internet, you must give the full URL with the date. I will do a separate little section going through analysis of this. For these videos, I just want to cover the setup and a brief overview. Hopefully you found that useful, and enjoy the experiment.